Claim assessment drones and damage monitoring sensors have become essential tools in insurance and disaster response operations. But when these devices reach the end of their life cycle, they introduce a new responsibility: disposing of them safely and sustainably. In this presentation, we explore what these devices are made of, what risks they pose, and how organizations can manage their end of life responsibly to protect both the environment and sensitive data. Technology has transformed how insurance carriers and disaster response teams evaluate damaged structures. Drones equipped with cameras, GPS modules, and infrared sensors allow assessors to inspect hazardous areas without putting themselves at risk. Damage sensors installed in buildings and infrastructure monitor changes that would otherwise go unnoticed. These tools have become indispensable for speeding up claims and improving safety. As these devices multiply across industries, the need for responsible disposal and recycling becomes increasingly urgent. Their growing presence means growing e-waste if we don't manage them properly. Understanding how they're used today helps us prepare for how we must handle them tomorrow. Assessment drones and sensors are built from complex components: cameras, batteries, processors, antennas, and specialized modules that operate in harsh conditions. Over time, environmental exposure, physical damage, and rapid technological advancement shorten their useful lifespan. Software updates may no longer support older hardware, and batteries eventually degrade. These devices ultimately become unusable, and every retired unit becomes a piece of specialized e-waste that must be handled appropriately. Planning for this life cycle is essential to prevent unsafe storage, improper disposal, and unnecessary environmental impact. Improper disposal of drones and sensors poses serious environmental and safety risks. Lithium-ion batteries can leak or ignite, releasing hazardous chemicals into soil and water. Circuit boards contain trace toxins like lead and mercury, which must not enter general waste streams. Sensor housings and drone frames are often built from plastics and composites that are long-lasting, non-biodegradable, and sometimes infused with flame-retardant chemicals. In addition to environmental hazards, many of these devices store sensitive data: images, videos, location logs, or structural assessments. Without proper wiping or destruction, this information can expose privacy risks or compromise security. Responsible disposal protects both the environment and the confidentiality of the people and places these tools assess. Despite the risks, claim assessment technology contains valuable materials that can be recovered. Circuit boards hold copper, aluminum, and trace gold. Plastic housings can sometimes be shredded and reused. Licensed recyclers are equipped to handle lithium batteries safely, extracting lithium for reuse in future energy applications. Many drone components, such as motors, gimbals, lenses, and sensor units, can be refurbished or repurposed for industrial or hobbyist use. By recycling these materials responsibly, organizations reduce environmental harm while supporting a circular economy for electronic components. Organizations that deploy large fleets of drones and sensors must plan ahead for their retirement. Life cycle planning should begin at procurement and continue through active use, maintenance, and disposal. Regular asset tracking helps determine when equipment should be replaced and prevents forgotten devices from piling up in storage. Partnering with licensed recyclers ensures proper handling of batteries, cameras, processors, and plastic housings, all while meeting compliance standards. Centralized take-back programs provide structured, secure pathways for data wiping, sorting, and responsible recycling. Not every drone or sensor needs to be discarded immediately. Many drones can be repaired by replacing worn-out rotors, imaging modules, or batteries. Sensors that malfunction due to firmware issues may only need recalibration or software updates. Extending the life of these devices reduces e-waste and saves organizations money. Even retired equipment can serve a purpose in educational environments. Engineering schools and training programs often welcome decommissioned drones to use for teaching and experimentation. Refurbishment and reuse not only benefit institutions but also support sustainability by reducing the volume of discarded electronics. Before recycling, sensitive data such as GPS logs or captured imagery must be securely removed to protect privacy. Proper data destruction eliminates the risk of information breaches. Lithium-ion batteries must be safely removed and isolated to avoid fire hazards during transport and processing. Working with licensed recyclers ensures environmentally responsible handling, proper material recovery, and compliance with all regulations. Documenting end-of-life processes promotes accountability and establishes a sustainable workflow for future technology cycles. As drones and sensors evolve at rapid speed, responsible disposal practices must evolve with them. Technological advancement should never come at the cost of environmental damage. Organizations can promote sustainability by selecting equipment with modular parts, replaceable batteries, and repair-friendly designs. Industry-wide commitment to ethical end-of-life practices helps create a circular life cycle where materials are reused, reclaimed, and recycled whenever possible. In the long run, proper disposal supports safer communities, cleaner environments, and a more sustainable technological future. Thank you for learning about responsible disposal of drones and damage assessment sensors. If your organization is ready to recycle outdated or damaged equipment safely and professionally, we are here to help. Responsible disposal today ensures safer, cleaner, and more sustainable assessment technologies for tomorrow.